Oh, the speakers work great, don't they? All right. All right. There is, go ahead and take a minute and write down your essential question. Okay. So I do try to record the lesson as we do it, and then it gets put up on YouTube / I put it on the Haiku Power School page. Okay. So that way, if you need to go back to it or you're absent, you don't miss the lesson. Okay. For most of the time, we will do that. We are currently in what I call a rebuilding year. That's why we're doing the notebooks the way we're doing them this year, because we have a new book and there are slight differences, not a whole lot, but there are slight differences in it. So we want to make sure that we're getting those slight differences picked up. The upside is those of you that are juniors, we will get, you will have a brand new notebook next year in BC. So you won't be the first year on that one. So, because I'm doing theirs as well this year. Okay. All right. So I did ask you to make sure you had a textbook in front of you. Then we're going to keep the calc textbooks on the left because my algebra 2s have to be stored on the right because theirs is consumable, but I don't make them carry the whole thing back and forth. So it is what it is this year. All right. We're going to talk about approximating the tangent line. This is a huge, huge thing. So this week, we're going to do things a little bit differently with this section than we have in the past. Okay. This section, out of all the sections in this chapter, is probably the one that is the ugliest, okay? Because we tend to teach you things the ugly way before we teach you things the nice way, all right? But this is how we connect the limits that we just did to what we call the derivatives, which is the next big topic, okay, that we have to cover. There's 3 big topics. Limits and derivatives are the first 2, okay? It's important that we do things this way, because there is usually a question, not a whole lot of questions, but maybe a multiple choice question that shows up this way with this limit process and the derivative on the AP test, okay? And I don't want you to ever come back and say, Mrs. Ballard, you didn't teach that to us, because I will have at least said, at least I taught it. We might not have reviewed it much, but at least we taught it. So our goal this week is that on Friday, we're not going to take a big test, but we're going to take kind of a quiz, okay? Maybe a 5 question on what we learned this week, all right? So my plan is to try to teach it Monday, Tuesday, Wednesday. Thursday, maybe do a little bit of reviewing class, and then Friday, we will take our little quiz thing on it, okay? And then that way, this stays off the big test for the chapter, okay? So we won't put this one on the big test for the chapter, all right? Sound good? And then we will move on to the rest of the chapter on next Monday. Both Lepis and I have to be out at some point this week, so that's why we're taking it a little slow on this one. And then don't worry, we will speed up. So, because they're caught up with us now. We can't have that, right? All right, so here's the first thing I want you to do is I want you to open your book to page 100. Okay? And I know we have never opened up a math book and read it before. Okay? However, when you go to college, you're going to probably have to do this at some point. All right? We might as well do a little bit of it now. I'm not going to do this all the time or every day, but every so often, there's some good information in there that I'm not going to regurgitate every single little word. I want you to try to read it a little bit. Okay? So, all I want is just page 100. Okay, so I'm going to give you about 2-3 minutes. I want everybody to read page 100. I'm going to read it too while you're reading it, so that way we can kind of time it all the same. Okay, so everybody take a few minutes, read page 100 to yourself. Maybe about another minute. If you're done, read the little blurb about Newton. Okay, so first of all, you read in there, hopefully, that they gave you a bunch of names of mathematicians that were working on calculus-like problems, right? The two big guys, a little bit of calculus history, are Newton and Leibniz, okay? And usually there's an argument over who actually invented calculus. They're both working on it at the same time simultaneously, okay, in different parts of the world, okay? You can see that their years overlap a little bit there, right? So basically what we're trying to look at throughout this chapter and really throughout the whole year, this concept gets repeated over and over and over and over. I guarantee you're going to see a tangent line on the free response questions. Okay, it's always embedded in one of them. They've embedded in a different one every year, but it's always embedded in one of them. So really, they're talking about a tangent line, and so we're talking about the equation of a line. What are the two things we need to write an equation of a line? Slope and what? Okay, we're gonna kill that concept today. So we don't do. Let me see if I can get this to right. Let's see. That's dead to us now. Okay, we don't use that anymore. We use this one: y minus y sub 1 equals m times x minus x sub 1. We need a slope and a point. Okay. Very rarely will we be able to get the y-intercept. The y-intercept might be the point they give us, great. And you don't have to reformat that equation in any way. As long as you can write that one, you've got it, okay? But that one is what we use. We no longer use y equals mx plus b, okay? So forget that one, all right? You don't have to do it again, at least not for my class. If you end up teaching Algebra 1 someday, maybe, okay? Or you have to teach your own kid Algebra 1. All right. Which you should all be able to do, right? Yeah. Okay, so they're talking about this concept of a tangent line, and they talked about these three pictures, right? All of these actually have a tangent to the curve, okay? So even though at some point, like on this one here, it kind of goes through it, but at some point it's really touching it right there, and this one here, it touches it right there, even though it goes through it here. I could draw another tangent line right there, okay? So a tangent line means at a point somewhere there is that the line touches it. I could draw another tangent line on that one at that point right there, right? So there's a lot of little tangent lines on here. Okay, it's really made up of a whole bunch of tangent lines really close to each other, right? Okay. All right. So now we're going to read page 101. So take a minute, read page 101, or actually a couple minutes. That one's a little bit ugly. You're done, read the little blurb that this is the tangent line problem. It's kind of an interesting quote. Okay, so if you notice that little quote on the left-hand side, good old Descartes, he says that this is the only thing about geometry that matters, right? So you took a whole course in geometry, and the only thing he thinks matters is the tangent to the curve. What is going on? I lost my connection here. You guys still have it, though. Isn't that interesting? Hold on, let me see if I can get my thing to connect again. It's going crazy. Connect. I can do it off my screen if I have to. There it goes. Okay. It's going. All right. So what, you guys all still have it on your screens though, right? Okay. So really what it's talking about here is a secant line. Okay. Oh, there it goes. All right. So what they're doing is well, it was really in the second sentence there. Essentially, the problem of finding the tangent line at a point boils down to the problem of finding the slope. And if you were sitting in my class last year, I talked to you about what AP Calculus is about. The calculus is entirely the study of the slope. Okay, so slope is extremely important to us. Okay, so what they did here is they took and this was all typed out there in the book, so you can see where I copied and pasted. Although I copied and pasted from the old book instead of the new book. All right, so that's formula for slope, right? We haven't probably seen it in a while, all right, because we didn't use it a ton last year. It was there, but we didn't calculate the slope a whole bunch. Then they've got these points on the graph here, okay? So this is, remember, this is an x value, that's a y value, right? To get the y value, all they did is they plugged this into the function. Does that make sense? Okay. So what they're doing in the numerator here is they're subbing in. They took, this is their y sub 2 that they subbed in, and this is their y sub 1. So they subbed in their y's. Okay, so I'm showing you how the formula is developed that they calculated. Okay, then they plugged in their x values. This is x sub 1, this is x sub 2, this is x sub 1, right? We agree? All right, then what they did is simplified. Do I really need these parentheses in this denominator here? No, the parentheses drop. What happens with the C's? They cancel, so I just have delta. What we read as delta x, but which is really called the change in x. Did we notice that notation? It's called the change in x, whereas the whole thing is real, or the numerator is the change in y. All right, and then this thing here is called the difference quotient. So this is what we're going to do to calculate the slope of a secant line. Okay. All right, so here's the awesome thing about this, and you hopefully read this in there. We can easily calculate a secant line because it's got 2 points. It's a lot harder to calculate a tangent line because it's only got 1 point, okay? But if I take these 2 points and they get closer and closer and closer together, don't they become the tangent line, okay? Or if we took their limit as we get closer and closer and closer to whatever that value is right there, we get the slope of the tangent line. Okay, so that's how we're going to do this. Is we're going to take the derivative is the limit of the secant line as we get closer and closer and closer to the point they want tangent. Okay. All right, so I think you have to fill that in, right? So go ahead and fill this chunk in here. Let's see if I can get something other than red. If it's only going to let me write in red. All right, where is my... Oh, my chart is probably wrong, the wrong page number. It's page 101. Not that it makes a difference for you. Didn't change all my page numbers. Okay. So let's talk about kind of some of the terminology that's in there. Okay. So what does the delta y mean? Change in y. What's the delta x mean? Change in x. And I will probably go back and forth between saying delta and change. Okay. We don't use it a whole lot, but we do use it. Notice that the slope is calculated by taking the limit as the change in x approaches 0. Okay. And then we plug in our function calculated at c plus delta x minus our function calculated at c all over delta x, whatever delta x is. Okay, so that's the formula we're going to use. All right, so we're going to find the slope of the tangent line to the graph at the given point. Okay, so the first thing I'm going to do is I'm going to write out my formula. Okay, so because that way I memorize it before Friday, right? Limit as delta x approaches 0. Sorry, it's going to do a little bit more of that where it went across like that. It's just a delta x of f of c plus delta x. See how it did that again? Minus f of c all over delta x. So have I done anything yet? No, I wrote the formula down, right? Okay. Now what is, if I'm thinking about my c value, it's coming from here. Is c the x value or the y value? It's the x value. So c is that 2. So I'm going to rewrite the formula and plug 2 into it. Okay. So the limit, and I'm plugging the 2 in where it's the c. So limit as delta x approaches 0 of f of 2 plus delta x minus f of 2 all over delta x. All right, so basically what you've done with that formula is you've written a set of instructions that you need to follow. Okay? So this is saying take the function and plug this mess into the function. What's my function? 2x minus 3. Okay, so limit as delta x approaches 0. So I've got 2x minus 3. I'm going to plug in this 2 plus delta x. Does that make sense? All I did was take the function. So it's substitution method, isn't it? It's like systems of equations with substitution method. I'm plugging this ugliness into the function. What does it say I plug into the function here? 2, right? The number 2. And I'm going to put a parentheses. 2. I'm going to use a different color so you can see the plug-in. Times the 2, right? That's the plug-in part. Minus 3. And then the delta x stays on the bottom. You're going to see why. All right. I know instinct's telling us we need to do some simplification, but let's think about back to limits. Am I allowed to just plug that 0 in? What's going to happen? The denominator is going to be 0. We can't have that. So our goal here is to try to get rid of that delta x in the denominator. Okay, so that's what we're trying to do. All right, so let's see what we can do to simplify this thing. What is instinct telling you to do here? Distribute. So we've got the limit as delta x. You can see how great my limit symbol is there. Approaches 0. What is 2 times 2? 4 plus 2 delta x minus 3 minus. All right, we can do all those numbers in our head, can't we? What's 2 times 2? 4 minus 3 is 1 over delta x. Come on. Okay. What's negative 3 and negative 1? Doesn't that all go away? We're in calculus. We can do all that in our head, can't we? They all can count. Okay. So we've got the limit as delta x approaches 0 of 2 delta x over delta x. Now what are we allowed to do? Cancel the delta x's. What's left behind? So my limit as delta x approach 0 is 2. We talked about the not boxing your answers thing, right? Okay. Really, I should go down the line. Yes, Antonio. On which step? This one here? On there we plug, so on there we followed this instruction here, and we plugged 2 plus delta x into this function here for the x, and then we also plugged the 2. This instruction said plug in the 2 for the x. So we plugged into the function twice in that line. We're ignoring the y value. We do that a lot, okay? Because we're only concerned about it approaching at that x value. Don't worry about the y, okay? Everybody okay with that? We all understand we're ignoring y? Okay. All right. We ready to move on to the next one? Okay. Let's try this again. All right. This one's a little bit uglier, or a lot uglier. Okay. Let's see if I have this one. Is this one in here? It is in there, I think. No, it doesn't. It's a different problem. Okay. All right, so we're going to find the slope of the tangent line and graph at the given point. So we're going to try this again. I'm going to start by writing my formula out. Limit as delta x approaches 0. And again, this is the formula. C plus delta x minus f of c all over delta x. And I'm writing it out so I have it memorized by Friday. So I can take a test on this on Friday. All right, quiz, whatever. Test, quiz, they're the same thing. It's just going to be less points, right? They all get thrown into the assessments category anyways. It'll be like 250 instead of 1,000, okay? All right, it still does. You still need it, though, this time of year, right? Because there isn't a lot in test points right now. In fact, I think there's nothing that I've graded at this point. All right, what am I plugging in for C? 1. Okay, so we've got the limit as delta x approaches 0 of f of 1 plus delta x minus f of 1 over delta x. All I've done is create my own specific formula now with the C plugged in. All right, now we're going to follow the instructions that we created. So anytime in this first part I see an x, or in this case it's a t, isn't it? Oh, you know what? We should have done delta t, huh? Let's fix those to t's, because I used a t notation in there, or the book did, or something. We're going to change them to t's. Is it any different than having an x there? No, it's the same thing. But they will throw the t notation in there from time to time, okay? Because t stands for time. Because they did say something about acceleration. They said something in the reading about velocity and acceleration, right? We hit those at some point, and those all have to deal with time. So that's why they replace the x with the t every so often. All right, so all we've done is we now know anytime we see a t in this function, we're going to plug in 1 plus delta t. Okay, so I'm going to do it in 2 different colors so that way you can see where I'm plugging in. Okay, so I see the first thing is a t squared plus 4 times t, right? So anytime I see a t, what did that function say I got to plug into it? 1 plus delta t. Okay. The back part says, what are we plugging into it? 1. So I've got 1. I'm going to do a parenthesis so I make sure my sign comes out right. I've got t squared plus 4 times t. So I've got to plug 1s into those. I'm going to do it in a different color so you can see the plug-in. 1, 1. And the good news is the denominator is just a lousy delta t, right? So the delta t is going to act like a variable, right? It acts like any other variable, just looks weird. Okay. So what does the squared mean that I do? I got to do it twice, right? I'm going to do some scratch work over here, okay? So 1 plus delta t times 1 plus delta t. Thank you for not saying you square the 1 and you square the delta t, because that's not what you do, right? We actually have to go back to good old FOIL, right? It really means we're foiling, okay? I don't know if we do hit any, but once in a while we'll hit a cubed on this one. Did we do the binomial? We did binomial expansion last year, right, with Pascal's triangle? Yeah, the cube works better with that. You can FOIL it out, but it works better with that. Every so often that one will come up. I won't put a cube on the test, I promise. I might put a squared, though. Okay. All right, so what's 1 times 1? 1. Oh, that's a good-looking 1. All right, 1 times delta t. Delta t, and don't I have another one of those? Yeah, could I rewrite it as 1 plus 2 delta t and go straight to that? I'm okay with that. Okay, what's delta t times delta t? And notice I put it in parentheses. Okay, because you're really, on that case, you are squaring the delta and squaring the t, so that's why you need the parentheses. I just write it delta. If I write it like this, the squared is only on the t. You see the difference? Okay, so that's a no-no. All right, so can't I now take this and substitute it in for this chunk right here? All right, so that's what I'm going to do. So the limit as delta t approaches 0 of 1 plus 2 delta t plus delta t, oh boy, let's switch screens, plus delta t squared minus. Okay. What is 1 squared? 1 plus 4 is what? 5. This is not turning out so good, is it? What did I do wrong? Nope, too far that way. I don't know where I got it. What?
What happens to 4 times 1 plus delta t? Yeah.
What happens to the... Oh, that's where I'm missing stuff. Thank you. I'm like, something's going really wrong. Something went wrong. Because it's not canceling like it's supposed to. Okay, I messed up. All right. What? Thank you for catching that. Is it qua? Is that right? Koi. Okay. See, you should have never told me. Now I'm going to get it wrong. Koi, right? Koi. Okay. Hey, I had him a really long time ago, so that was like my first or second year here at Talkwitz. So it's amazing that I still remember the name. Okay. Here, at least I didn't call you T, right?
Yeah.
Although that would be an honor, I would think. Right? All right. So what I got to distribute that 4 in, right? I missed that step. So plus 4 delta t. Now what? It was a minus 5, right? Oops. Sorry. Okay, so this chunk here came from this piece in the middle that I skipped over. And then the 5 came from the back. All right, now we are ready to do some canceling here, aren't we? Do we see anything that's going to cancel? Okay, so 1 plus 4 is 5 minus 5 is 0. So that all is going to go away. Okay? Now, I'm going to work smart, not hard, because I'm running out of space on that screen, right? So, what do you notice about what's left? What's in all of them? A delta t. I could combine the 2 and the 4 together, right? What do I get when I combine the 2 and the 4 together? 6 delta t. I'm just going to assume that I have that there already. I'm not going to write a whole nother line for that. So, you're listening. When I have a term in there that's kind of a factor that's common, what do I do with it? Can I take it out? Okay, so I'm gonna pull a greatest common factor of delta t out, because ultimately, don't I want to get rid of that delta t in the denominator? So this is our trick to doing that. So we take out a delta t. I know that 2 plus 4 was 6, so I'm going to put those together. Okay, and then I'm left in this term here. I'm left with 1 more t, right? All over delta t. T didn't. It likes to flip on me, doesn't it? More so than with the other board. Okay, why did taking out the delta t benefit us? We can cancel the delta t's, right? Okay. What am I now? I'm now at the point where I could plug in my limit. I'm not going to rewrite the whole thing to just plug the limit in. What am I plugging in for the delta t? 0. So what am I end up getting? 6 is my answer. Okay. It's not pretty today. Okay. It's a little bit tedious. It's not that it's hard. It's tedious. All right. And usually what kills us isn't the calculus part. The calculus part is easy. That was a limit and a formula, right? It's the algebra in between. Okay. I think there's 2 or 3 more, right? We do. We'll get there. All right. So we are supposed to look at the slope of the tangent line at the given points here. Okay. So the first thing so notice, the problem change, the question changed, didn't it? Oh, it didn't. It stayed the same. Never mind, it stayed the same. Okay. So it gave us 2 different points this time, right? So, are you guys paying attention? Okay. So, the 2 different points, I don't want to have to go through that I don't want to have to do this twice, do I? So instead of plugging in a number for the C value, I'm going to keep it generic and plug an X in there. Okay, so I'm going to rewrite out our little C formula with an X plugged into it. Okay, and then we're going to use that, and we're going to solve that in general, and then plug in the 0 and the -1. Okay, so I'm doing it a little bit differently. So we have f of, it was C minus delta squared, right? Oh, sorry, I forgot my limit, didn't I? Don't let me mess it up at the beginning already. All right, so the limit as x approaches, as delta x approaches 0. All right, of f, where did it go? F, and instead of writing a C, I'm going to write an x plus delta x, because I'm going to do this for a generic coordinate x, y, minus f of x all over delta x. So again, where we had the c's in the formula before, I put x's just because I wanted to make it more confusing. No, it's because I'm trying to do it in general for any x. Okay? All right. So this is basically saying, well, for my formula, I'm going to take this and plug it in for x, right? And then I'm going to take an x and plug it in for x. All right, so let's go for it. Limit as delta x approaches 0. So I'm going to take my function. What's my function right now? So I'm going to do squared plus 1, and I'm going to plug in. What does it say I got to plug in first? X plus delta x. Okay. And then I'm going to subtract, maybe. Come on. Subtract. I'm going to see, what am I supposed to plug into my function next? Are we going to be able to tell that we plug in an x? No. This is basically the way I like to think about this, is write the function the way it looks, right? That's all that it basically is. But I'd probably put parentheses around it because of the minus sign. So that's going to swap our signs. And then we've got a delta x. Okay. What does the squared mean I have to do on that thing? Foil it. Okay, good. So we've got x plus delta x times x plus delta x. So what's x times x? X squared. X times delta x, check this out, is x delta x. And I have that twice. And then delta x times delta x is delta x squared. How many of these things do I have in the middle? 2. So x squared plus 2x delta x plus delta x squared. There was something like that in the first week of homework work. Okay. This is now going to get go in for this thing here, right? That's what it looks like foiled out. So the limit as delta x approaches 0 of x squared plus 2x delta x plus delta x squared. And then notice I have a plus 1 there, right? What do I have to do with this negative? Distribute. So negative x squared minus 1 over delta
Triana
x.
Dennis, please report to counseling office. Triana Dennis, please report to counseling.
Sorry. Oops, too far. There you go. Yeah. This is our last one today, okay? All right, why is it not letting me change color? Come on, come back. It's not letting me do it. All right, we're going to go with the same color, I guess. All right, what's going to cancel? A 1, and I also heard that x squared cancels, right? The benefit to that is now can't I take out a greatest common factor? Because our goal is to be able to cancel that delta x, isn't it? So the limit as delta x approaches 0. I'm taking out a delta x. In this piece here, I'm left behind with a 2x. And that piece I have a delta x left behind. Delta x all over delta x. Oops, sorry. This machine does not like to stay on the same slide very long, does it? All right, what happens? The delta x cancels. Okay. Am I at this point able to plug in my limit? Yes, I'm going to plug in the 0, so I'm left with the final answer of 2x, and then we would plug in the... I'm sorry, I didn't get it finished. We would plug those two numbers into this. So at 0, 1, we would just say that it's 2 times 0, which is... It's not 2, 0, right? And then at -1, 2, sorry that I went too long. You get 2 times -1, which is -2. Sorry, it's lagging. I don't know why it wants to do that after every slide. Okay? All right, we're going to stop there. I will post homework in Power School. Okay? See what you can do with it tonight. Yes, Antonio. Oh, sorry. On the first step, look at your screen. It's still probably on your screen. But the first step when we're plugging in the x, right? All I did was I plugged in an x instead of a c. Does that make sense? Yeah. Yeah, right here. What's wrong?
Is that when we're plugging in the -1?
Right here, we distributed the -1. Yeah. So we didn't plug these in because I wanted to do 2 of them. Does that make sense? There were 2 points, so instead of doing each point separately and having to do this process twice, I did it in general so I could just plug in the x at the end. So I did it slightly differently than I did on this side. Okay, does that make sense? I did a generic x. I took the derivative with the x in it, and then at the end I plugged in my value for my x. So I only had, because if not, I would have had to do this process twice.
Okay, so for this one, when you reach this point, you just chose one of the x's to put in?
No. I distributed this one here should have just been an x, or you put the f on there. You shouldn't have had that f there. That's what's confusing you. Because then all I did was distribute that negative in. You see, if I didn't have that f there, it's distribute. Look at mine. Okay, see that it's just a negative. There's no f. I distribute. That's where I got a negative and a negative from.
Oh, +1 is right there because it's not in the parentheses.
Yep, that's not in the parentheses, so that's where that came from. Sorry.
Oh.
Okay. It's always the algebra, right? It's never the calculus.
Miss Ballard,
Yes.
Tomorrow your period stuff's going to be online, right?
I will get it up. Yep.
Because I won't be here.
Okay.
This is going to be surgery. So.
Okay.